Hi friends, this video is entirely for the NTPC exam. I'm just going to cover the important topics which is been in the cbse textbook for science, and I tried to include all the relevant information from that textbook. I give you an outline for what is going to be asked in the in the NTPC exam. So I just begin with the chemistry topic, the first chapter for class 10th, the chemical reaction and equation. In this chapter, the outline of this chapter consisting of some reaction and type of reaction and corrosion and the lime, that is slacked and quick lime, and how they are formed. These are the outline for this chapter. And here this chapter begins with the begin with the burning of magnesium. As we all know that when magnesium burns in air, will produce MgO. The balanced reaction is 2Mg gives 2Mg plus O2 gives 2MgO. So here the importance of this reaction is here the reaction is will produce a dazzling white flame. It will produce a dazzling white flame, and also this MgO is a white powder. That is when magnesium reacts with oxygen. That is when magnesium burns, it will burns with a dazzling white flame, and the result will be a white powder. This result will be a white powder. And also the next one is when iron react with water, so here it is the reaction. When iron react with water, it will produce hydrogen. So that they can be used this hydrogen, that is when iron react with water, what is generated, which gas is generated. This can be used, that can be made as an objective question. So this is the importance of this reaction. And also, what is the oxidation state of iron in this reaction? It is definitely 8/3. The oxidation state of iron in this reaction is 8/3. But here we have 3 iron. Among these, 2 iron have an oxidation state of 3 and 1 iron has an oxidation state of 2. Okay, what is quick lime? What is slacked lime? Quick lime is calcium oxide, which is called quick lime, and slacked lime, calcium hydroxide, is called slacked lime. Among these two, quick lime is the most reactive one, and CaOH, this is slacked lime, is the most purest one. So, and also when as we know that quick lime is more reactive, when we are adding some water to quick lime, it will directly converted into slacked lime, that is less reactive one. So this reaction is being used for converting calcium oxide, that is quick lime, to slacked lime. So this can be used for creating some objective, that is what happen when we are adding water to the quick lime. So this is very important. And also as we know that, as I already told that calcium oxide, that is quick lime is more reactive and slacked lime is less reactive. So when converting a quick lime to slacked lime, this slacked lime, which is less reactive, can be used for our daily purposes. For example, for changing the acidity of soil, etc. So this is the importance of this reaction. Okay, and also this slacked lime produced here can be used for whitewashing the surface. This is a very important question. This is slacked lime produced here can be used for whitewashing the surface. What is the chemistry behind this? So when we are whitewashing this calcium hydroxide, that is slacked lime, in the atmosphere, when we are whitewashing this calcium hydroxide. So after whitewashing, this calcium hydroxide will slowly react with the carbon dioxide in the atmosphere, will generate calcium carbonate plus H2O. So the calcium carbonate formed here will produce or provide a white shiny appearance to the wall, and hence we are used for this for whitewashing the wall. This is the chemistry behind why we are using calcium hydroxide for whitewashing. And also here this reaction, that is adding water to the quicklime, is an exothermic reaction, is also an exothermic reaction, exothermic. And here the temperature can be raised up to a 49 degrees Celsius. That is why we are called as an exothermic reaction. So another one of the important exothermic reaction as mentioned in the CBSE is the decomposition of vegetable matter into compost, is an example for an exothermic reaction. So vegetable matter when decomposing in the soil is also gives heat generation of heat, that is it is an exothermic reaction. Okay, now I tried to give you some general classification of reactions. First one is combination reaction. Here I have written here that it is a combination reaction. What is combination reaction? In case of a combination reaction, two components or two reactants will combine to produce a single one. That is first one, and in the second case, which is the example for combination reaction, this is the formation of slacked lime from quicklime. That is here the second one is formation of water from hydrogen and oxygen. Both these are combination reaction. And the next one is decomposition reaction. What is a decomposition reaction? In the case of a decomposition reaction, first one and second one, here what happened actually, here the single component is being split into two or more. The first and second one is the decomposition reaction. So here the second one, here it is calcium carbonate, that is limestone, calcium carbonate or limestone, which is actually we are also seen in the previous topic, that is why we are using the slacked lime for creating white shiny surface for painting, etc. So here the limestone after eating will convert into calcium oxide. What is calcium oxide? That is quicklime and carbon dioxide. So this reaction is very important, and also it is a decomposition reaction. Now I'm just going to discuss some practical applications where we are actually using decomposition reaction. The first one is the reaction when white silver chloride turns gray in sunlight. That is when silver chloride, which is a solid, and when it is opened in sunlight, it will turns to silver. It will produce silver plus chlorine. That is here it is white, that is white silver chloride turned to gray in sunlight. This is due to the decomposition reaction. And these reactions are also used in the photographic plate. So when white silver chloride turns opened in sunlight, it turns to gray silver. This color is being changed, and this reaction is actually used in the photographic plate. And the next one is when yellow silver bromide, okay, silver bromide, this is its color is yellow, and when it is also opened in sunlight, here the silver bromide, which is yellow in color, when it is opened in sunlight, it's converted into silver plus bromide. Here silver is solid, and here also the yellow silver bromide turns to gray. It is also turns to gray. So here it's also when here these two reactions are the examples for practical applications where decomposition reaction is used. Here in the decomposition reaction, one single component is being decomposed into two or more parts. So this silver chloride, which is white in color, it turns to gray after sunlight is being hit on it, and with the silver bromide, which is yellow in color, and it is also turns to gray after sunlight is being hit on it. So this two decomposition reaction is very important. From this two reaction, it's clear that the silver chloride is, or silver is very sensitive to light, and hence it is being used in the photographic plate. This can be also been converted into an objective question. The next class of reaction is displacement reaction. In the case of a displacement reaction, here it is clear that here copper sulfate. In this copper sulfate, the copper is being displaced by iron. Here in the product side, here it is the place for copper, but it's been replaced by iron. Such a reaction is called a displacement reaction. The first, two, and third, these three examples are well illustrative to the displacement reactions. That is, here also copper is replaced by zinc here, and also here also copper is being replaced by lead. The next class of reaction is oxidation and reduction. In oxidation reaction and reduction reactions, there are some criteria to confirm which is these reactions are. So in the case of an oxidation reaction, there is a loss of electrons, but in the case of a reduction reaction, there is a gain of electron, as per the first point. Then the second point, when there is an oxidation reaction, there is an increase in the oxidation number, but in the case of a reduction reaction, there is a decrease in the oxidation number. And also in the case of a oxidation reaction, there is a loss of hydrogen, and in the case of a reduction reaction, there is a gain of hydrogen. And these are the main three things that we need to keep in mind regarding oxidation and reduction reactions. Oxidation of copper. Oxidation of copper, that is when copper, as we know that copper is a reddish brown in appearance. So a reddish brown copper, when react with the oxygen, that is, it is undergoing oxidation in presence of some heat, and it will generate copper oxide. This balanced reaction looks like this. So copper is a reddish brown in color, reddish brown color. When it is oxidized, it will generate a black copper oxide. It is black in color. So this is the oxidation of copper. So here, when we are passing some hydrogen around this black copper oxide, that is when copper oxide, which is actually black in color, and we are passing hydrogen through it, and it is being converted into copper plus H2O. So here this reaction is an oxidation reaction, and here this one is a reduction reaction. So, and here the color change is very important. That is, the copper, which is reddish brown in color, is oxidized under oxidation being converted into black. And here, when we are passing hydrogen over this black copper oxide, it has been again recover its color into reddish brown. This is an example, practical example of oxidation and reduction reactions. Okay, the next important topic is corrosion. As we all know about corrosion, and it is an unavoidable thing in the nature. So these three are very important example which is provided in the NCERT textbook. That is green coating on copper. Green coating of copper is an example for is due to the effect of corrosion. That is, copper on undergoing corrosion will produce a green coating. This can be the practical example for this is Statue of Liberty. So Statue of Liberty, as it is being at the time of its construction, it is reddish brown in color, but after the corrosion, its color is being changed into green. So presently it is in green color, but at the time of construction it is reddish brown in color. So this is due to the corrosion. And then black coating on silver is another example for corrosion. The last one is a reddish brown color on iron. We all have a familiar with this example. Okay, this is all about corrosion, and this three example is very important, and their color change can also be used to create some objectives. Then the last topic is rancidity. What is rancidity? Complete or incomplete oxidation or hydrolysis of fat and oils when exposed to air, light or moisture. And this process, that is complete or incomplete oxidation, will change the smell and taste of this vegetable oil, fats, etc. And we called this, that is when there is a change in the color, smell and taste of this oil, we call these are rancid. So this is the oxidation, that is oxidation of oils and fat, and this will result in the change in smell, taste, etc. So rancidity is a class of oxidation which is actually happen in the case of vegetable oils and fats, etc. And to prevent this, to prevent the food to get rancid, or to prevent the rancidity to be happen, we are filling the packets, food packet, with along with the nitrogen. So we are not using oxygen to fill packets, we are filling nitrogen. It is because to prevent the rancidity. Okay, in the NCERT textbook they are also provided such in this information, that is Indian coins. Indian coins are made by using ferritic stainless steel. Ferritic stainless steel, which is a mixture of 83% of iron and 17% of chromium. Okay, this is all about the first chapter. Thank you.